Today we're going to look at solving inequalities. The learning targets that you're going to try to do is to solve inequalities. Remembering inequalities are like less than, greater than symbols. In this first example on your notes, there's a little table here talking about two cell phone plans offered by a cellular company. The first plan has a monthly access fee of $35. There's 400 included minutes. Additional minutes are 40 cents. Plan 2, $55. 650 minutes are included, 35 cents for additional minutes. They want you to answer a few questions here. So let's look at the first questions. It says, write an inequality, remember, less than, greater than type symbols, to compare the price of plan 1 to the price of plan 2. So our two prices here for plan 1 are $35. The other one is $55. We want a symbol in between. In this case, since 35 is less than 55, we want to use the less than symbol. Less than symbol points at the smaller thing. All right, let's check out the next question here. Next one says, write an inequality to compare the price of additional minutes in plan 1 compared to the price of additional minutes in plan 2. Our additional minutes here are 40 cents and 35 cents. And in this case, 40 cents is greater than 35 cents, so we'd want to use a greater than symbol. Open end should be to the bigger thing. Okay, question 3 says, if Cooney knows that she will use no more than 400 minutes per month, which plan is best for her? So 400 minutes means that she's going to be using only included minutes here. So if she only uses included minutes, then we could say that the best plan probably would be plan 1, since that's cheaper than the $55. So in this case, looks like plan 1 is the best deal. All right, the next one, or the last question here, says if she uses 1,000 minutes per month, which plan is best for her? All right, now we got a little figuring out to do, because now if she uses 1,000 minutes, she's going to go over for both plan 1 and plan 2. So we want to figure out which one's going to be a better one. If we go with plan 1, she's going to have to pay $35 for sure, plus she's going to pay she's going to need an additional 600 minutes, because 4 minutes are included, so 600 minutes, and the price for that is 40 cents for plan 1. If we multiply that out and add it to 35, that comes out to equal a total of $275. Okay, let's check out plan 2 now. If we do plan 2, that's going to be $55. Plus here, if we do a little math, 1,000 minutes minus 650 leaves us with 350 additional minutes. This one's a little cheaper, only 35 cents. If we do some multiplying here and add 55, this comes out to be $177.50. The cheaper of these is definitely plan 2. So in this case, if she uses 1,000 minutes, plan 2 is going to be the better deal. Okay, so you got kind of a taste of inequalities there. When you solve with inequalities, you use the same or follow the same steps as you do in solving an equation, except, the one big exception here, except when you multiply or divide by a negative number. Then you must reverse or switch the direction of the inequality symbol. Also, we're going to be doing some graphing of inequalities. Whenever you see less than or greater than signs, you want to use a open circle when graphing. If they include the point with the little equal sign underneath the inequality, then we want to use a solid or shaded in dot to indicate the point. All right, so let's do some solving here. On number 5 on your sheet, they want us to solve out this inequality. Well, if we want to solve for y, just like we looked at before with solving, you want to get the variable by itself. So we want to do the opposite here. Let's move our number to the other side. If we have minus 9, we'd want to add 9 to make that equal 0. Okay, that cancels out. We're left with 11y on this side. Over here, if we add that up, that's 22. We don't need to do anything with the symbol here. We didn't multiply or divide, so keep it the same direction. Now we're dividing. We're dividing by 11 because y is being multiplied by 11. If we divide by 11, now we're just left with y. 22 divided by 11 is 2. Now we are dividing here, but we're dividing by a positive 11. This was a positive number that we divided by. We don't need to switch any signs. It again stays the same way. So our answer to this one is all the numbers y that are greater than 2. Now when we graph that out, we want to make a number line here, get some numbers on there. Okay, now we want to list where our point starts. So it's going to start at 2. Okay, we do not in this case need to fill it in because we're not counting 2. It's just the numbers greater than 2, and then we want to shade. So numbers greater than 2 are to the right. So we want to indicate by shading everything to the right. So the graph of this one would look like that. All right. Why don't you pause a quick, try number 6, and then we'll check how you did. All right, let's see how you did on this one. Hopefully you started by subtracting 9. Okay, now you're left with 7x is greater than or equal to, remember you're minusing mine from a negative 12, this should be even a bigger negative number, negative 21. Now we're dividing by 7. Okay, negative 21 divided by 7 is negative 3. Keep the symbol in the same way to this one. Even though the 21 is negative, the number we're dividing by was positive. It's not a negative number. We should keep the symbol the same way. So this should be the answer, that x is greater than negative 3. To graph this one, again, get some numbers on your number line here. Label it. And then we want to do some graphing here. Negative 3, find that point. This one we do want to shade in, because it could be equal to it as well. And then we want to put our arrow in. It's greater than, the numbers greater than, negative 3 are going to be to the right. All right. On number 7, this one a little bit different than some of the ones we've solved so far. If you have some kind of fraction or division going on, first get everything else to the other side. So on this one, we would want to first subtract 1. Okay, get anything that's not associated with the fraction away first. So now we got 2n minus 6 over 5 is greater than negative 1. Now we want to get rid of this fraction. Now fractions are really dividing. We're dividing by 5 here. The opposite of dividing, the opposite operation of dividing is multiplying. So if we multiply here both sides by 5, that cancels out with this 5 here. So to undo division, we multiply. Now we are multiplying. It was by a positive 5 though, so we don't need to switch the inequality symbol. So now we have 2n minus 6 is greater than negative 1 times 5 is negative 5. Now this looks similar to the ones we've done so far. Add 6. So we got 2n is greater than 1. Last step, divide by 2 here. Now 2 does not divide nicely into 1. So you could either write this as 2 ways. You could write that n is greater than 1/2 and leave it as a fraction, or you could have that's greater than 0.5. Either one is fine. Either one of these would be an okay answer. Again, to graph it on one like this, might be a better idea to maybe go by halves here when graphing. Kind of having a line in between, you could do something like that. We don't want to count half because it doesn't have the or equals to, and again, this is greater than, numbers greater than or to the right. All right, one last one here. Let's do this one. On one like this, everything's on the same side, so maybe move the number to the other side. We could start by subtracting 14 since this 14 is positive. Okay, so now we got negative 8n left because we got this negative sign right here is less than or equal to negative 14. I forgot a line there. Now we got to divide. Here we're dividing by a negative 8. Okay, now this is one we're dividing by a negative number. So on the left side, this cancels out, that's fine. On the right side, if we divide two negatives, that's going to turn into a positive number. We're going to end up with 1.75 when we do that. And the symbol, now since we're dividing by a negative, this is one where you do need to reverse the direction of the sign. So instead of less than or equals, it turns into greater than or equal to 1.75. Okay, if we want to graph this one now, we could maybe go by fourths or quarters here. So we could have something like this, where every line is worth 0.25. Okay, so this would 1.75. This would be like 1.5 is here. 1.75 would be this third line right here. We do want to count the points, so shade it in, and it's greater than should be to that. So whenever you get dividing by a negative, you need to reverse the sign. All right, the other thing we're going to look at is just maybe writing out some different types of inequality type statements. Some things you should look for when doing these. If you run into any type of statements that say no more than, or if you see at most, those are two different statements that indicate less than or equal to. So if you're not more than something, or at most, that means you have some kind of top number you can't go more than, then you want to use less than or equal to. Some other statements that you may run into that are kind of similar: no less than, and at least. These indicate there's some bottom number that you are going to be talking about, and everything else is greater. So this would be greater than or equal to if you see any of these. Two other ones that kind of look similar to some ones we looked at in a previous notes video is greater than and is less than. Okay, when you see the word is with it, that's going to indicate it's an equality rather than like adding or subtracting. So is greater than or is less than symbols would look like that. So when there's an is in front of it, then that's usually going to mean you're talking about some kind of comparison. All right, so on number 9 here, it says twice the sum of a number, and 5 is no more than 3 times that same number increased by 11. Let's see if we can write a statement out for this. So we talked about before in a previous one, twice means we're multiplying by 2. We're multiplying 2 to a sum, which means two numbers must have already been added together. We're going to need a parenthesis here. When you multiply twice the sum or twice the difference, then that operation already happened. So the two things that are being added here looks like a number and 5. So some type of variable like n or x added with 5, because sum means you are adding. All right, next is no more than 3 times that same number. Okay, is no more than. No more than indicates that it's not going to be greater than, it has to be equal to or less than. So less than or equal to symbol. 3 times that same number. So if we are multiplying by 3 times, 3 multiplied to the same variable n, increased by 11, adding 11. So this would be a statement for this one. And that's all they ask us to do in this one, is write it out. They don't ask us to solve it. All right, why don't you pause it, try number 10 here, see if you can figure out that one. All right, let's see how you did. 9 less than a number. Okay, that means there's a number that we are taking 9 away from, subtracting. Okay, this less than is not the less than symbol because is not in front of it. All right, is at most. Okay, at most, that means it could be the biggest number or less than that. That same number, same variable, divided by 2. And here you could have something like this would be fine. Also, if you used a fraction to do it, that would work too. So something like this would be an answer. All right, this next one is one you could see later, maybe when taking the ACT to get into college. It says homemade bracelets are for sale for $4.75 each. Which inequality can be used to find out how many bracelets Caitlin can buy for herself and her friends if she wants to spend no more than $22? Okay, so here, right here is one of those key phrases we talked about. No more than. No more than means it has to be less than or equal to the amount of money she has, $22. 22 is a total. There's nothing being multiplied to that. So I think we can rule out C and D here because in each of these, 22 is being multiplied by a variable. We don't want that. So it's got to be A or B. She's spending $4.75 each. So $4.75 times however many she's going to buy. It appears A is the answer to this one. So if you saw one like this on the ACT, that's where you're looking for those key phrases. All right, last one, another word problem type situation here. The Middletown High School girls basketball team wants to make at least $2,000 on their annual mulch sale. The team makes $2.50 on each bag of mulch sold. How many bags should the team sell? Okay, so $2.50 on each bag. So if we do $2.50 times the number of bags, we'll use B for bags here. And they want to sell at least. That's our key phrase here. That means greater than the amount of money here, 2,000. So greater than or equal to $2,000. At least they want to be greater than or that same amount. So to solve this one, looks like we'd want to divide by $2.50, the amount per bag, and we can figure it out. We do not need to reverse the sign here because we're dividing by a positive number. And if you divide that out, it looks like 800 bags. They need to sell greater than or equal to 800 bags in order to make the amount of money they want. All right, try some of these out on your worksheet.